Humanity has always looked to the stars. We've dreamt of exploring the cosmos. Now, a new frontier beckons us, space mining. This isn't science fiction. It's about to become reality. Imagine a future where resources are plentiful. That's the promise of space mining. We're on the cusp of a new era. This is our next giant leap. Look up at the night sky. The stars we see represent a vast, untapped reservoir of resources. Asteroids, moons, and planets hold unimaginable wealth. They contain precious metals, water ice, and rare earth elements, everything we need to sustain our civilization. We're talking about a cosmic abundance that dwarfs anything found on Earth. For too long, we've been confined to our planet, limited by its finite resources. Space mining offers a solution. It promises to break these limitations, to open up a new era of prosperity. Imagine a future where resource scarcity is a distant memory, replaced by a universe of abundance. The potential benefits of space mining extend far beyond simply acquiring resources. It's about developing new technologies, pushing the boundaries of science. It's about creating new industries and jobs, fueling economic growth on Earth and in space. It's about ensuring a brighter future for generations to come. Space mining is not just a distant dream, it's a rapidly approaching reality. Private companies and government agencies are investing heavily. They are developing technologies, launching missions, and laying the groundwork for a new space-based economy. We're on the verge of a paradigm shift, one that will reshape our world. The journey won't be without its challenges. There are technological hurdles to overcome, ethical considerations to address, and international collaborations to forge. But the potential rewards are too great to ignore. The promise of space mining is simply too compelling to resist. As we venture into this uncharted territory, we carry with us the hopes and dreams of humanity. We are embarking on a journey of exploration, innovation, and progress. This is the dawn of a new era, an era where the resources of space fuel our ambitions and propel us towards a brighter future. We're witnessing a modern-day space race, not to plant flags, but to mine celestial bodies. Governments and private companies are investing billions, their goal to unlock the riches of space. This isn't a distant dream, it's happening right now. Companies like Planetary Resources and Deep Space Industries are leading the charge. They're developing spacecraft and technologies to identify, capture, and process resources in space. These pioneers are driven by a vision of a future where space mining is commonplace. Governments are also getting involved. Luxembourg has positioned itself as a hub for space mining, attracting companies and investment. The United States, with its space exploration legacy, has passed legislation recognizing the right to mine celestial bodies. The race for space resources is on, and the stakes are astronomical. The first step in space mining is identifying promising targets. Think of it like the gold rush of the Old West, but on a cosmic scale. Scientists and engineers are using powerful telescopes and spacecraft to map the solar system, searching for asteroids and other celestial bodies rich in valuable resources. These cosmic prospectors are looking for specific resources. Water ice found on asteroids and the moon is vital for life support and can be broken down into hydrogen and oxygen for rocket fuel. Platinum group metals, rare on Earth but abundant in asteroids, are crucial for electronics and other industries. The data collected by these cosmic prospectors is helping us understand the composition of celestial bodies and identify the most promising targets for mining. This information is critical for planning missions and developing the technologies needed to extract and process resources in the harsh environment of space. Asteroids, remnants from the early solar system, are like floating treasure chests in space. They come in various sizes and compositions, and many are rich in valuable resources. Some are primarily metallic, containing vast quantities of iron, nickel, and precious metals. Others are carbonaceous, rich in water ice and organic compounds. One type of asteroid, known as a near-Earth asteroid, or NEA, is particularly attractive for mining. These asteroids orbit relatively close to Earth, making them easier and cheaper to reach. Some NEAs are estimated to contain trillions of dollars worth of resources. The potential of asteroid mining is staggering. It could provide us with an almost inexhaustible supply of resources, reducing our reliance on Earth's finite reserves. Imagine a future where we mine asteroids for the materials to build space habitats, spacecraft, and even entire cities in space. The Moon, our closest celestial neighbor, holds vast resource potential. Water ice in shadowed craters could support lunar bases. The surface is rich in helium-3 for fusion reactors. Countries and companies plan missions for resource utilization. Establishing a sustainable lunar presence is the goal. The Moon is key to our multi-planetary future. Imagine a future where resource scarcity is a distant memory. A future where we have access to an almost limitless supply of precious metals, rare earth elements, and water ice. This is the promise of space mining, a paradigm shift from scarcity to abundance. For millennia, humanity has been confined to Earth, forced to make do with its finite resources. This limitation has shaped our history, fueled conflicts, and driven innovation. But imagine breaking free from these constraints, tapping into the vast resources scattered throughout our solar system. Space mining has the potential to usher in a new age of abundance, not just for a select few, but for all of humanity. The resources extracted from asteroids, moons, and planets could be used to address global challenges, from poverty and hunger to climate change and resource depletion. It's about creating a future where everyone has the opportunity to thrive. Our planet faces unprecedented challenges. Population growth and resource demand push Earth's systems to their limits. Space mining offers a bold solution. Rare earth elements are crucial for modern technologies. Their supply is concentrated, causing geopolitical tensions. Asteroids offer a sustainable source. Space mining is about more than just extracting resources. It's about pushing the boundaries of human ingenuity and driving technological innovation. The challenges of operating in the harsh environment of space demand creative solutions, leading to breakthroughs in robotics materials, science propulsion systems, and more. Imagine robots capable of autonomously navigating and mining asteroid spacecraft, powered by ion engines that can travel vast distances using minimal fuel, and 3D printers that can construct structures in space using locally sourced materials. These are just a few examples of the technological marvels that space mining could inspire. The spin-offs from these technological advancements would be immense. New materials developed for space applications could revolutionize industries on Earth, from aerospace and construction to medicine and electronics. The knowledge gained from operating in space could lead to breakthroughs in fields like renewable energy, robotics, and artificial intelligence. Section 4. Expanding our economic horizons. Space mining has the potential to create a new economic paradigm, one that extends beyond the confines of Earth. It could lead to the emergence of new industries, the creation of countless high-paying jobs, and trillions of dollars in economic activity. The construction and operation of space mining infrastructure, the transportation of resources, and the development of new space-based industries would require a skilled workforce, creating employment opportunities in fields like engineering, manufacturing, logistics, and research. This new space economy could fuel economic growth for decades to come. Moreover, the abundance of resources in space could lead to a paradigm shift in manufacturing. Instead of transporting raw materials from Earth, we could build factories in space, closer to the source of resources. This would reduce transportation costs, minimize environmental impact, and open up new possibilities for large-scale construction and manufacturing in space. Section 1. The Dragon's Teeth. Every great endeavor comes with its own set of challenges. Space mining is no exception. The obstacles are vast and daunting. Space is harsh and unforgiving. Temperatures fluctuate wildly. Radiation poses a constant threat. The vacuum leaves no room for error. Any mistake can be catastrophic. Distance is another issue. Even the closest asteroids are millions of miles away. This poses logistical nightmares. Micrometeoroids are a constant danger. Overcoming these challenges requires cutting-edge technology and understanding of physics. Section 2. The cost of reaching for the stars. Space exploration has always been an expensive endeavor, and space mining is no exception. The initial investment required to develop the necessary technologies, build the spacecraft, and launch missions is astronomical, often reaching into the billions of dollars. Consider the cost of developing powerful rockets capable of carrying heavy mining equipment to distant asteroids, or the sophisticated robotics needed to operate autonomously in the harsh conditions of space. These technologies don't come cheap. Furthermore, the long-term operational costs of space mining are substantial. Maintaining communication with distant spacecraft, providing technical support, and transporting resources back to Earth all require significant financial resources. This raises the question, will the potential profits from space mining outweigh the enormous upfront and ongoing costs? Only time will tell, but one thing is certain. Space mining will require a level of financial investment on a scale rarely seen in human history. As we venture into the cosmos, eager to tap into its riches, we must tread carefully. Our solar system is a delicate ecosystem, governed by intricate gravitational forces and billions of years of cosmic evolution. Disturbing this balance, even slightly, could have unforeseen and potentially disastrous consequences. Imagine, for instance, the impact of a miscalculated asteroid deflection. What if, in our quest for resources, we inadvertently nudge a celestial body onto a collision course with Earth? The consequences could be catastrophic. Then there's the issue of space debris. Every rocket launch, every satellite deployment leaves behind a trail of debris that can linger in orbit for centuries. Space mining, if not conducted responsibly, could exacerbate this problem, creating hazards for future missions and potentially even jeopardizing our access to space. We must develop sustainable practices that minimize our impact on the delicate celestial dance of our solar system. Here on Earth, we have laws and regulations governing the extraction of resources. But in the vast expanse of space, who owns the rights to celestial bodies? Who decides how these resources should be used and shared? These questions are at the heart of a rapidly evolving field, space law. The 1967 Outer Space Treaty, signed by over 100 countries, forms the foundation of international space law. It states that space is the province of all mankind and prohibits the national appropriation of celestial bodies. However, the treaty is vague on the issue of resource extraction, leading to different interpretations and potential conflicts. As space mining becomes a reality, we need a clear and comprehensive legal framework to ensure responsible and equitable access to space resources. This framework should address issues of ownership, environmental protection, profit sharing, and dispute resolution. It's a complex challenge, requiring international cooperation and a shared vision for the future of space exploration. The challenge of space mining lies in our human nature. History shows new resources often lead to conflict and exploitation. We must break this cycle in the cosmos. Space mining offers a chance for cooperation and sustainability. Resources should benefit all humanity, not just a few. This requires a shift in perspective. Embrace a long-term vision for responsible exploration. Ensure benefits are shared equitably among all. This is the true challenge of space mining. The future of space mining is a tapestry woven from dreams, ambition, and the relentless pursuit of scientific progress. It's a future where humanity transcends the boundaries of Earth, tapping into the boundless resources of our solar system to fuel a new era of prosperity, innovation, and discovery. Imagine a future where bustling spaceports dot our planet, launching spacecraft laden with mining equipment towards distant asteroids and the lunar surface. Imagine massive space-based platforms, processing raw materials into usable resources, fueling the growth of industries both on Earth and in space. This is not a far-fetched fantasy. It's a future well within our grasp. The seeds of this future are being sown today by visionary entrepreneurs, dedicated scientists, and forward-thinking governments. The path ahead is clear: to boldly embrace the challenges and opportunities of space mining, forging a future where the stars themselves become a resource for human progress. The future of space mining is inextricably linked to the advancement of technology. Just as the telescope revolutionized our understanding of the cosmos, so too will new technologies revolutionize our ability to extract and utilize space resources. Imagine self-replicating robots, capable of mining and processing resources autonomously, multiplying their numbers exponentially as they build the infrastructure for a space-based economy. Imagine spacecraft powered by fusion engines, capable of reaching any destination within our solar system in a matter of days, slashing transportation costs, and opening up new frontiers for exploration and resource extraction. And imagine advanced 3D printing technologies, capable of constructing massive structures in space using locally sourced materials, from space habitats and research stations to solar power satellites and even entire cities in orbit. These technologies, once confined to the realm of science fiction, are rapidly becoming a reality, driven by the immense potential of space mining. The pursuit of space mining is not a solitary endeavor. It's a global enterprise, requiring collaboration and cooperation among nations. We are witnessing the rise of new spacefaring nations, eager to stake their claim in this new frontier and reap the benefits of space resources. Countries like Luxembourg, with its progressive space legislation and investment in space mining companies, are positioning themselves as hubs for this burgeoning industry. China, with its ambitious space program and growing technological prowess, is emerging as a major player in the quest for space resources. And nations with a long legacy of space exploration, like the United States and Russia, are adapting their strategies to embrace the opportunities of space mining. This global collaboration is essential, not only for sharing the costs and risks of space exploration, but also for ensuring that the benefits of space resources are shared equitably among all of humanity. India, with its proud heritage of scientific achievement and its burgeoning space program, is poised to play a pivotal role in the future of space mining. The nation's technological prowess, its entrepreneurial spirit, and its commitment to sustainable development make it an ideal candidate to become a leader in this exciting new frontier. Imagine Indian spacecraft, equipped with cutting-edge mining technology, extracting water ice from the lunar surface to fuel future missions to Mars and beyond. Imagine Indian companies, at the forefront of space resource utilization, developing innovative technologies for processing asteroids and manufacturing in space. And imagine India, a nation with a deep respect for the cosmos and a commitment to global cooperation, using its expertise in space mining to foster international partnerships and ensure that the benefits of space resources reach every corner of our planet. India's journey to the stars has just begun, and its potential in the field of space mining is truly astronomical. The future of space mining is about expanding our horizons, pushing human ingenuity, and creating limitless possibilities. Imagine asteroid mining creating new industries, boosting the global economy and raising living standards. Space resources could fuel clean energy technologies, combating climate change for a sustainable future. Knowledge from space mining unlocks scientific discoveries, deepening our understanding of the universe. It inspires future generations to reach for the stars. We stand at the cusp of a new era, one where the boundless resources of our solar system beckon us to reach out and grasp the stars. Space mining, once a staple of science fiction, is rapidly becoming a tangible reality. Fueled by human ingenuity and technological advancements, the journey ahead demands dedication and global cooperation. The potential rewards are too great to ignore. Space mining holds the key to solving humanity's pressing challenges. Let us answer the call with boldness and wisdom.